Our lesson today is on introduction to functions. And so start with this activating strategy, pause the video, and try it out. So the first thing you would need to do is plug in the first x value into x. So right here we're going to put -2. And so 3 minus 2 is going to give me 1. So then my first ordered pair would be -2, 1. Notice that an ordered pair does go in parentheses. And then it says graph it. When I am graphing, oh, that's not very straight. Pretend it's straight. -2, so I put a couple slash marks here, and 1, up 1. So I go -2, up 1, and then I'm going to put my dot right about there. Obviously, if you have graph paper or something else, it's going to look better than that. Continue on and do the same thing. -1, you're going to get 3 minus 1 is 2. So I'm going to erase this. And, okay. There we go. Here's our 5 ordered pairs. In every single one, you do the same thing. Just plug it in. So 0 gives us 3 because 0 plus 3 is still 3. So that's this one. And then graphing it the way that I showed you, go -2, up 1. Each ordered pair only has 1 point associated with it. So the next one, -1, 2, we go over to -1 on x and then up to 2 on y, and that's where the point goes. 0, when x is 0, then it's going to be on the y-axis, and it goes up to 3 here. Then we go over to 1, go up to 4, go to 2, go up to 5. This is a discrete function, or well, it is a function, but we'll get to that. It's discrete because we're not connecting the dots. We only have, these are the only values that are included. Our objectives are to identify functions and find the domain and range of relations and functions. Vocabulary, everything that was just there: relation, domain, range, and function. Relationships can be represented by a set of ordered pairs called a relation. So an example, in the scoring systems of some track meets, for first place you get 5 points, second place you get 3 points, and for third place you get 2 points, and for fourth place you get 1 point. The scoring system is a relation, so it can be shown by the set of ordered pairs. Notice the set is in curly brackets, and the ordered pairs are in parentheses. So first place, 5 points, second place, 3 points, third place, 2 points. Fourth place, 1 point. That's our ordered pairs. But we can also show relations in tables, graphs, and mapping diagrams. So we want to do exactly that. We have these ordered pairs, and we want to put it into a table, a graph, and mapping diagram. So we'll start with the table. The x values, and so that's the first value in each of the ordered pairs. 2, 4, 6. That will go in x. The second one, 3, 7, 8, goes under y. And that's all you have to do for a table. And a table should look like this. It should have cells marking x and y on the top cells, and then your values will follow. As a graph. So we're going to plot the ordered pairs. And again, this will be discrete because we have ordered pairs. We just have dots. So 2, 3, and then the next one is 4. So go over to 4 on x and up to 7 on y. And then go over to 6 and up to 8 to get your third one. And that's all we need to do there. Make sure that you're not trying to plot 2 points for one coordinate pair. There's only 1 point associated. Mapping diagram. This one's a little bit different. We draw 2 figures, kind of rectangles with rounded corners. The first one is going to be our x values. The second one is going to be our y values. So again, we're just going to write them in just like we did with the table. And then we draw arrows to show which y value corresponds to the x value. Sometimes your arrows will cross one another. Write your values in ascending order. So the lowest value first, 2, 4, 6, 3, 7, 8. And you'll see in this that they're not all done that way, but that's the way I need you to do it. So this says check it out. So pause the video and then try it out. You're going to have one slide that will have your table, the next the graph, or the next the mapping diagram. So do one and check it before you do the next one. So here is the table. Notice again, we're using the first value in each ordered pair goes in X. The second value goes in Y. So your graph, take your X value, go across the X to the value 1 up to 3 on Y, and the same with the other 2 points. And your mapping diagram, 2 separated figures, first one for X, second one for Y, and arrows to the corresponding value from X to Y. The domain of a relation is the set of the first coordinates or x values of the ordered pairs. The range of a relation is the set of second coordinates or y values of the ordered pairs. The domain of the track meet scoring system is 1, 2, 3, and 4 to correspond with first, second, third, and fourth place. And then the range is the point values, 5, 3, 2, 1, but remember I want you to write it 1, 2, 3, 5. So now we need to find the domain and range of the relation. So what we're going to do here is we're going to go from the endpoint down and see where our x value is. And then from this endpoint, go down and see where our x value is. So this corresponds to 1. This corresponds to 5. So our domain is from 1 to 5. This is a continuous function because we have a line, and it means that all the values in between are included. Notice these are filled in circles, so those endpoints are also included. Do the same thing for y. We go over from each of the endpoints to the y-axis, and we see that it goes from 3 to 4. So our range goes from 3 to 4. Okay, so the domain value, in words, the domain value is all x values from 1 through 5 inclusive, meaning including the endpoints. The range value is all y values from 3 through 4 inclusive, again, including the endpoints. But we can also write it as an inequality. So for our domain, we have 1 is less than or equal to x is less than or equal to 5. Notice when we do the range, we're going to use y instead of x because our range is up and down. So 3 is less than or equal to y is less than or equal to 4. Okay, try this one out. Domain and range of the relation. Put it in set notation, so that means in the curly brackets, and put it in ascending order, which means you start with the smallest value and go up. When when the same value occurs 2 or more times, you still only write it once when you're giving the domain and range. Pause the video and write down the domain and range. So here's the values, and then we're going to write them in set notation, and they didn't write them the way that I said, so they fail. It should be 1, 2, 5, 6. This one is in the right order because -4 is less than -1 is less than 0. So that's a basic idea, though, of how to write it. In the curly brackets, separated by commas, notice we had one set for here, the domain, one set for here, the range. Now you try it. So the domain was 1, 4, and 8, and the range values are 1 and 4. It's not 1, 1, and 4 because 1 is still 1. So here is what it should look like. And you can just write a D and an R instead of writing domain and range. And in class, remember I said we could use mushka because I made up that word for range. So if you want to write an M, that's okay too. But on tests, go with R. A function is a special type of relation that pairs each domain value with exactly one range value. So here, we're going to give the domain and range of the relation, then tell whether it is a function and explain why. So let's look at our values. We have 3 for our x values, 3, 5, 4, and here's another 3. We have in the range -2, -1, 0, and 1. So we have 3 going to -2 and also going to 1. So this would not be a function because we do not have exactly one domain paired with one range. The domain value 3 is paired with the values -2 and 1. And here we just have a different format, but look at how this goes. We have -4 goes to 2, -8 goes to 2, 4 goes to 1, and 5 goes to 1. So each of these domain values only goes to one value in the range. So this is a function. It's okay for the range values to be paired with more than one x value, but it's not okay for the x value to be paired with more than one range value. So here's our domain, here's our range, and this is a function because each domain value is paired with exactly one range value. So we're going to look again at domain and range. And in order to get the domain, I have to go to the farthest point on x, which is going to be here, and then the farthest point on x to the right is going to be here. So it's actually going to go, this is by ones, so this is -3, -4, -5, and then it goes 1, 2, 3. So from -5 to 3 is our domain. And then the other direction for the y, for the range, and that would be -2 to 1. And then when you set it up using an inequality, and remember to put the x and the y in the middle. If you say -5 is less than or equal to 3, that's true, but it doesn't tell me that it's a domain. So this is not a function because you can see that x is going to have 2 values on most places on this. So that's not allowed. So it is not a function. Another thing is called the vertical line test. So if you can draw a vertical line and it only goes through one value on y, then it's a function. And it needs to be in all places. So like I could draw a vertical line here, and that's only going to go through one. But that isn't enough to tell me what's happening in this function or non-function, in this relation. So this one is not a function because the values, the domain values have more than one range value, most of them. So try this out for yourself. There's A and B, 2 separate problems. Give the domain and range and tell whether it's a function and why you think that. So looking at the x values in the ordered pairs, we have -6, -4, 1, and 8. And notice this time they did put it in the right order. And then in the range, we have 1, 2, and 9. So we only have our x values one time, so they each are paired with only one range value. So it is a function. In our mapping, we have 2, 3, 4 for our domain. We have -5, -4, -3 for our range. But look at what we have here. We have 2 has 2 different y values. So this is not a function. It is paired with, the 2 is paired with both -5 and -4. And that's it. I'll go ahead and let this run, the lesson quiz. You can pause the video and try it. See how you did. And then a part 2. And that's it.